Hi there, in this video I'm going to make the oil pump for the Jerry Howell V-twin. So bearing in mind that this drawing is twice the size, and the oil pump consists of two parts really, the body and the cover, and I'm going to make it out of this piece of brass. So I've just faced it off and turned this outside diameter down so it fits within this area here. That's a nice slip fit, and from this one piece I'm going to make the body and the cover. So I think first of all what I need to do is to drill and ream this to 1/8 of an inch, and I've already centre drilled. And now there's a requirement to open this up to 1/4 of an inch in diameter and to a depth of 0.11 of an inch, and this is to hold the ball bearing. Now I've not got a boring bar that small. I don't know if such things exist, but what I'm going to do, it's probably not a wise approach this, but I've got a 2-float end mill 1/4 of an inch. So just put that in the chuck, and with this being a metric lathe, 0.11 of an inch relates to two full turns of the tailstock plus 40 increments. I can't say I'm happy with that. A bit of a sloppy fit is that. So I'm going to try again. So I'll face it off again, and then I think I'll drill with a 6mm drill bit, and I've got a 1/4 inch reamer, but it's tapered on the end, so I'll have to do a little change in the calculations. Well, I hope I'm not overthinking this simple operation, but the problem I've got is this 1/4 of an inch reamer. So this little taper here on the end, and that's 95 thou wide. So in theory, to go to a depth of 0.110, I need to add 0.110 and 0.095 together, and that gives me over here a depth that I need to drill and ream to as 0.205. Now, just as a double check, the sort of taper on here on the drill bit, I've worked out to be, I know that angle's 120 degrees, so over here we've got 60 degrees, and to work out this depth here, I've got tan 60 is equal to 0.118, which is 3mm, divided by x, so this distance. So x works out to be 68 thou. So that's alright, because obviously it'll be there's enough, it'll be getting enough material out for this reamer to have effect. And this other cavity on this side is going to be just over 80 thou deep. The total width of this piece is let me see, 30 thou plus 270 thou, so that's 0.3 of an inch. So the total width 0.3 of an inch, and we take this off, and that leaves just over 14 thou here. But I think it'll work out okay. But I'll do the drilling and reaming off camera. Well, it's slightly better, but it's still not a press fit, so I think it'll need just a little bit of Loctite on it. So what I need to do now is to create a boss on here. Well, the boss needs to be 0.312 of an inch in diameter. I know that this diameter is 1.124, so that gives me a difference of 0.812. Divide that by 2, I get 0.406. So I'm going to take 10th hour off at a time, and I've got a dial on here, so I'll just go to that depth of 0.406. So I'm going to part this off 20th hour over size. I think I'll just sharpen this up a bit. Okay, so I think what I'm going to do is I'm going to just use the bandsaw to cut it off. That seemed to go okay. I need to turn this down now, and I think I'm going to put it on the mill and get it down to the correct width. And what I also did off camera was I made the cover in exactly the same manner as I made that, just slightly different dimensions. And on this one, I think I'm going to put that in a collet chuck and turn that down to the correct width on the lathe. So there's a slight gap between the actual collet face and the piece, so I've put this bit of shim in there. Now I'm going to measure the width. That comes in at 72 thou, so I need to take another 9 thou off. Now unfortunately I've not got a collet chuck that's big enough for that, so what I'm going to do is use these V-blocks to hold it, and I'm going to support the piece with this piece of aluminium, so I'll just sort of go on top like that. And just put these on, these magnets, to try and hold it to the bottom. It's got a tendency to just open up at the bottom, so I'll just nip it up and try and avoid that. So what I've decided to do to stop it nipping up at the bottom, I've got these old slip gauges which just fit in nicely at the top, so I'll loosen the vise off, put these at the bottom, and then that should work, hopefully. So I can tighten it up nice and tight. Not quite, I need smaller slip gauges. That's okay now. Well, so far so good. So I think it's back over to the mill to start machining this area here. Well, now's the requirement to drill a couple of recesses for the 13-tooth gears, and there are no dimensions for the diameter of these recesses, but they need to be just slightly bigger than the actual gears, because obviously the gears are going to act as a pump. So I've worked out that I can probably just get away with an 8mm diameter end mill, and I need to go to a depth of 80.5 thou. So the distance between centres for these gears is 0.272 of an inch, and the holes are at a 30-degree angle. So using a bit of trig, I've worked out that the X coordinate needs to be 0.2355, and the Y coordinate needs to be 0.136, both minus, by the way. So I've put it on that position. Now it's a matter of drilling again to a depth of 80.5 thou. And now there's a requirement to drill a number of holes at different locations and at different diameters, but it's a little bit complicated, and it's very sort of small area, so I'll do all that off camera. Well, believe it or not, this is an engine I'm making, and not a watch or a clock. And that will fit into there at some point. Now, I did mess up a little bit, a couple of places. I misinterpreted one of the sort of descriptions, and what I did was I tapped these two holes here, and I shouldn't have done. I should have tapped the other four. So I need to revisit that at some point. It's not a great deal, because these are going to be opened up anyway at some point. And the other bit I messed up on is this hole here. I shouldn't have gone right through. That's going to meet a hole from here, an intake. So what I'm going to have to do on that one is to just create a little blank there. That's no great shakes. But apart from that, everything's looking fine. Now, I used an 11mm end mill here, just to mark the position. I couldn't go right through, because I'd have hit the V-blocks. Now, the instructions suggest what you do is you use this as a template to drill through those 6 holes and some other ones. These 1, 2, 3, 4, 5, 6, and I don't really fancy doing it that way. I think what I'm going to do is, you know, if I centre this properly in the V-block, I can use the DRO in exactly the same way that I used it here, and you know, that should result in a near perfect cover. So that's the plan. So I'm using exactly the same setup for the cover that I have done for the body, and I'm using the coaxial indicator to make sure we're on centre. I'm just 2 thou away from the original on the x-axis, so I'm happy with that. So I'll just reset the DRO, and I'll just follow the instructions again, going round and drill those holes, but I'll do all that off camera, so it's all boring stuff. Well, that seems to have worked out okay. So what I'm going to do next is I'm going to open this up, and then there's a requirement to put a flat on here somewhere and drill through into one of the oil holes. That one, I think. So there's a requirement to put a flat on here, 1/4 of an inch wide, and it's got to be parallel with the 2 outside holes here. So what I've done is just put some rods through, put some parallels underneath, pushed it down, tightened the vise up. So it's just a matter of taking a few thou off, I think. Probably another 5 thou, so that'll take it to a total of 10 thou. That looks about perfect. So what I need to do now is to drill an oil intake hole from here to join this hole here. But I'll do that bit off camera. So to finish off this cutout here, what I've decided to do is just to drill and tap some M3 holes, which are the same distance as the 2 gear centres. Countersunk that to take that little boss. So what I'll do is I'll bolt that on there, put this in the vise on the mill, line it up, and just continue to drill through that piece there. Fingers crossed this will work out okay. So the bolt heads are just slightly higher than this surface here, so I'm going to use a couple of washers on top of these threaded holes, and my plan is to bolt it down. The piece is in exactly the same position as before when I machine this, so I'll bolt it down and then just mill out that area here to match that. That seemed to work. So I've just put one of the gears on a test spindle, and that's how it'll operate. Pulling oil in from this side and pushing it out through this side, and when the proper spindle is in place, the cover will go on like that. So I've used some Loctite to put this drive gear on the shaft, and I think the idea is that you put that gear on there and you Loctite it in place on the shaft. But I don't want to do that just at the moment. I'll do that closer to assembly, final assembly, because I'm not too sure whether or not, well, how to adjust it. And I don't want to get Loctite in there otherwise it's going to Loctite the shaft to the piece of brass body. So it's a bit of a faff really. But just to demonstrate how it will look, is that will go in like that. Obviously the gear will be in there. Then we put the cover on. Bolt the cover on. I won't do that just now. And then put this cover on. Realised I think I need to machine this area here a little bit just to give way to the cover. So if we just take the cover off and assemble it. Yeah, that's more like it. Finally got there in the end. And with the shaft in place, that's how it'll turn. That turns as well. That's for the hall sensors, I think, for the timing. So it's getting there. And while I remember, the instructions say you drill a hole through the oil gallery here and into this hole here. But strangely enough, if I drill sort of straight in, it's going to miss it. So I don't know whether that needs to be drilled at an angle. I need to give that some thought before I do anything with that. But apart from that, I think it's pretty much there. Well, I must say I found that extremely challenging. I mean, the tolerances are so fine. The width of the gears, half a thou less than the actual sort of width of the chamber. But it needs to be that close to enable the pump to work. I think I got there. Once I've Loctited this gear in the middle, I think it'll be a-okay. But anyway, I hope you found the video of interest, and I hope to see you later.